are seeing the topic that is a differential equation. The subtopic is a higher order linear differential equation with constant coefficients. So we'll see one example of that. We have the example of second order because it is a d square plus 3d plus 2 into y equals to we are having e to the power x. Okay. Now if you observe the RHS part, that is e raised to the power x. So we are having a one different method to find out its particular integral. Okay, so we'll see that later on. So first of all, our first job is to find out the auxiliary equation and its roots. Okay, so we just write down the given equation as it is. Auxiliary equation is given by d is replaced by m. It is m square plus 3m plus 2 equals to 0. Factorize this. This will be m plus 1 m plus 2 equals to it is 0. Okay, the roots will be then minus 1 and minus 2. The roots are real as well as different. So complementary function will be c1 e raised to the power minus x for this minus 1 plus c2 e raised to the power minus 2x. So it is very simple to write down the complementary function for this. Okay, because roots are real and different. We have already seen the cases. Now for the pi, it is 1 upon that function of d, the RHS part. Now first of all, we have to check whether this pi can be solved by the cases that already we have seen, the short cases to find out the pi, that is of e raised to the power ax, then sin x, cos x, then a polynomial, but it does not fit into the any case because it is e raised to the power x. Okay, we are having, so that's why we will solve this pi by using the general method. In general method, what we do, I factorize this denominator into the linear factor. So इसके linear factor बनाएंगे हम, so that will be d plus 1 and d plus 2, that you can factorize here because 1 into 2, that is 2, 1 plus 2 is what, 3, which is present here. That's why we do the factorization. Now we do the partial fraction. I write down this fraction as 1 upon d plus 1 minus 1 upon d plus 2. And one more thing, partial fraction is not possible for all the fraction. There is a condition that degree of numerator is strictly less than the degree of denominator. तो यहाँ पे degree of denominator कितना, it is what, 2. Degree of numerator is 0. d to the power 0 is there, it is 0. So degree of numerator is strictly less than degree of denominator. So we can do the partial fraction. Okay. So I just write down this quantity as 1 upon d plus 1 minus 1 upon d plus 2. I just take a cross multiplication. So I will get this fraction then. Okay. Then further multiplying this factor over e raised to the power x, and then this factor over again e raised to the power x. Now we apply the general case formula. I have just written here, it is 1 upon d plus ax and 1 upon d minus ax. So 1 upon d plus ax के लिए formula क्या बनेगा, e raised to the power minus ax integration of e raised to the power plus ax x into dx. Then 1 upon d minus x के लिए बनेगा e raised to the power ax integration d minus a, तो e raised to the power ax integration of e raised to the power minus ax x into dx. हमको d plus का फॉर्मूला यहाँ पे यूज़ करना है because we are having the term d plus 1 and d plus 2. Okay, so 1 upon d plus 1, the formula will be what it is, e raised to the power minus x integration e raised to the power plus x. Then it is this part e raised to the power x into dx. Same we apply here 1 upon d plus 2 के लिए कैसा होगा, e raised to the power minus 2x integration of e raised to the power plus 2x e raised to the power x into it is dx. Okay, now to solve this integral, what we do, I will substitute e raised to the power x equals to it is what, t. Take a derivative of this quantity, that is e raised to the power x dx equals to dt. Now substituting this quantity here, e raised to the power x dx is dt, this is e raised to the power t, and integration of e raised to the power t is e raised to the power t. This is simple. The second integral now, in the second integral I break this e raised to the power 2x into the two parts, that is e raised to the power x and e raised to the power x, and we replace e raised to the power x dx by dt. Okay, and then one e raised to the power x is left, that is replaced by t, and here we are having e raised to the power t. So we are having the integration of t e raised to the power t. Now do the integration of this quantity by integration by parts. We can do it directly. First function, then integration of second minus, now take a derivative of this, take integration of this quantity. Okay, this way we do the integration directly, or otherwise you can use the formula first function integration of second minus integration of derivative of first integration of second. उसको यूज़ कीजिए, या अदरवाइज डायरेक्टली भी हम कर सकते हैं यहाँ पे। जैसे मैं आपको बताया कि इसको फर्स्ट लिया, इसका इंटीग्रेशन किया, पुट अ माइनस साइन, टेक अ डेरिवेटिव ऑफ दिस, टेक इंटीग्रेशन ऑफ दिस। ओके, नाउ आई टेक द कॉमन e raised to the power t, बाहर निकाल लिए, देन वी आर हैविंग t minus 1 here, replacing the t by what, e raised to the power x. So we got this quantity then further. Now after replacing, I just multiply this term by these two terms, ठीक है, इससे मल्टीप्लाई किया तो e raised to the power x मल्टीप्लाई होगा e raised to the power minus 2x से, बेसिस से में पावर ऐड हो गए, दैट इज minus 2x into it is what, x. So minus 2x into x, that will be e raised to the power minus x, ठीक है, into e raised to the power x we are having, plus this is multiplied here. Now these two terms are get cancelled, we are left with this one, only one term, that is our required pi. Just combine that complementary function and the particular integral to write down the complete solution, that is y is equal to cf plus pi. This gives the complete solution. So this way we solve the example over what it is, general case pi. ओके, बाकी CF तो हम नॉर्मल मेथड से निकाल रहे हैं, PI के लिए बस आपको सोचना है, बिकॉज इट इज़ नॉट फिट इनटू द एनी केसेस दैट वी हैव सीन प्रीवियसली, नॉट टू द एक्सपोनेंशियल, नॉट टू द साइन कॉस, और नॉट टू दिस अ पॉलिनोमियल ऑफ डिग्री m, या फिर फोर्थ केस फिफ्थ केस जो भी देखिए हमने, वहाँ कहीं फिट नहीं हो रहा है, देयरफॉर वी आर सॉल्विंग दिस बाय व्हाट, जनरल मेथड. क्लियर? सो दिस वे वी सॉल्व द एग्जाम्पल और द हायर ऑर्डर लीनियर डिफरेंशियल इक्वेशन विद कांस्टेंट कोएफिशिएंट्स. थैंक यू.